Assalamu alaikum wa rahmatullah. Welcome dear student in your Google Classroom of Orthodontic for 4th class. With you your lecturer Dr. Lamis Khader Muhammad, POP department. I am orthodontist at the POP department, College of Dentistry of Babylon University. Today I will give you the lecture 4 of your syllabus and represented lecture 2 for the orthodontic tooth movement. In the previous lecture, we're talking about the tooth movement as a simple definition, its types, and the center of resistance and center of rotation. And at the end, we're talking about the optimal force that I need for each type of orthodontic tooth movement. Today, in our lecture, we will take 3 important topics talking about the biological response of tooth movement, theory of tooth movement, and phases of tooth movement. So let us begin our lecture with the first topic. Before I talking about the biological response, let me give you the principle that every orthodontic treatment depends on it. The principle for each orthodontic treatment based on that when the force, a prolonged pressure or a prolonged optimal force applied to the tooth movement will be occur as a result of the metabolism or chemical changes or the changes that will be occur in the bone. I mean, due to the bone remodeling process occur in the bone adjacent to the tooth, that represented by the appearance of osteoclast cell on the pressure side and osteoclast cell on the osteoclast cell on the tension side and osteoclast cell on the pressure side. These cells and other components will be present in the PD ligament space. So we should know that the PD ligaments have a very important and vital role in the orthodontic movement. So let us now talking about the PD ligament as a structure and its function in general. Firstly, the PD ligament space occupy a width surrounded all the roots, uniform width. The average width of it is equal to 0.2 to 0.4 million. But you should keep in your mind that this average of width of the PD ligament is when the tooth is present in function during the mastication and in the occlusion. While during the eruption of the tooth and when there a new erupted tooth, the width of this PD ligament space will be equal to 0.5 million. Later on, it will be reduced to this average. The component of the PD ligament, if we take a cross-section of the PD ligament, this is the cross-section represented this is the pulp, this is the dentine, this is the cementum, this is the area of PD ligament space, and this is the alveolar bone of the socket surrounded the tooth. The first component of the PD ligament, it will be include the collagenous fiber bundles. The collagenous fiber bundles, you know, it is consist of different type according to the position of it, but all of it will be parallel bundles, parallel to each other, present in the embedded in the cementum of the tooth in one side and in the alveolar bone of the bony socket and lamella dura on the other side. Its role in fixation of the tooth within its socket. The second component is the cellular element and vesicular and neural elements. The cellular element that will be present in the PD ligament, it will be in the condition of mesenchymal cell. I mean, it will be undifferentiated cells. Later on, these mesenchymal cell will be differentiated according to what happened in the PD ligament space and differentiated in different type of active cell like the fibroblast cell responsible for the formation of collagen matrix and fibers, the osteoblast cell responsible for the formation of bone, osteoclast cell responsible for the resorption of bone, a fibroclast cell responsible for the removing of the old collagen fibers, and cementoblast, odontoblast, and etc. The last component of the PD ligament is the tissue fluid. Like any other part of the tissue in the body, there will be a fluid occupy this space. This fluid acts as a shock absorber. So the PD ligaments have a role in providing a cushioning against the blow or shock that apply to the tooth, have a role in the eruption of the tooth, and also, as you can see, that it have a vital role in inducing the tooth movement due to the presence of these three important components of the PD ligament structures. Now, what are the rules of these components? We will discuss it and explain if we're talking about the second topic of our lecture, which are the theory of orthodontic tooth movement. Generally, we have different type of theories, but the most important one is the bioelectrical theory and pressure tension theory. In the bioelectrical theory, it is based on that the tooth movement will be occur when we have changes in the metabolism of the bone. These changes in the metabolism of the bone will be controlled by the electrical signal, which results from the deformation that occur in the crystalline structure as a result of alveolar bone flex or bend. So, the steps of bioelectrical theory that will be aimed by tooth movement, it will include the following. After the application of force to the tooth, what will be happen according to the bioelectrical theory? Firstly, there will be alveolar bone bends in response to the applied force. As a result of this alveolar bone bends, there will be a deformation of a crystalline structure like the hydroxyapatite crystal and the collagen fibers. As a result of this deformation in the crystalline structure, there will be a creation or generation of electrical signal or piezoelectrical signal. This piezoelectrical signal will stimulate it and control the changes in the bone metabolism. After the occurrence of changes in bone metabolism, there will be a differentiation for the cellular element present in the PD ligament space, as mentioned previously, which are in as a mesenchymal cell undifferentiated. It will be after the changes in the bone metabolism, it will be differentiated into what? The most important for us for the bone remodeling is the osteoclast cell and osteoblast cell. So after the activation of these cells, there will be a bone resorption and bone apposition, and the process of bone remodeling will be occur and end with tooth movement. These are the steps of bioelectrical theory. What about the pressure tension theory? What happened? Firstly, the pressure tension theory represented the classical theory for orthodontic tooth movement. It will be depend on the chemical changes, chemical mediator, rather than the electrical signal like that occur in bioelectrical theory. So, what will happen if we applied a force to the tooth according to pressure tension theory? This is the tooth. After the application of force, you can see that the tooth shifts in its position in the direction of force. And so the first step after the force application, there will be a shifting in tooth position within the PD ligament space. As a result of this shifting to one side and out from other side, there will be a creation of compressing and stretching side. You can see here This is the on the left side of the tooth. There a shortening in the length of the collagen fiber, so it is called a compressing PD ligament and compressing or pressure side. On the other side, which is represented the right side of the root and the side of force application, there will be elongation in the length of the fibers and our stretching of the fiber, and this side is called a tension side. As a result of creation of these two sides, there will be changes will be occur when next to other. First of one is there will be alteration in the blood flow as a result of compressing of the PD ligament space and reducing in its side and compressing in the collagen fibers. There will be also a compressing in the blood vessel present in the pressure side, and as a result of this, there will be a reduce or decrease in the level of blood flow. While in the tension side, there will be, as a result of stretching or tension, there will be a dilatation of the blood vessel that result in either increase the level of blood flow or maintain the same level of blood flow in it. Also, the changes in the blood flow result in changes in the chemical environments, like the level of oxygen. The level of oxygen in the pressure side will be full or decrease, while it will be increase in the tension side. The other proportional chemical mediator also will be changes. These changes in the chemical environment either directly stimulated the mesenchymal cell in the PD ligament to induce a cellular differentiation, or it will be stimulate the other chemical messenger that will later on result in stimulated the mesenchymal cell in PD ligament and induce a cellular differentiation. The most important for us for the cells is the differentiation of active osteoclast and active osteoblast that responsible for inducing the bone remodeling. So after the action of osteoclast cell on the pressure side by bone removing and the action of osteoblast cell on the tension side by bone opposition, the bone remodeling will be occur and end with a tooth movement. So these are the two theory of orthodontic tooth movement. I hope the difference between them is clear for you. Now, what about the last topic of our lecture about the phases of orthodontic tooth movement? We have three phases for orthodontic tooth movement: initial phase, lag phase, and post-lag phase. You can see that I give different color for each phases. It is look like the color of traffic lights, red, yellow, and green. And also it reflects what happened in each phases. So let us start first with the initial phase. In the initial phase, firstly, the tooth, you can see here the tooth without located in its socket. The width of the PD ligament surrounding the root is equal to each surrounded all the tooth, and no problem happened. In the initial phase, after the application of force to the tooth, it will be characteristic by sudden displacement of the tooth within its socket. You can see the changes in the crown of the tooth and changes in the position of the root after the application of force. This represented the sudden displacement of the tooth within its socket, which is represent the initial phase of tooth movement. The amount of this displacement will be the same if we applied light force or heavy force. After the initial phase have been occurred, it will be continue into the lag phase. Into the lag phase, it will be characteristic by either very little or no tooth movement will be occurred. So what will happen in lag phase? The lag phase will represent the phase of cellular differentiation for the cells present in the PD ligament space. So there will be a osteoclast cell will be differentiated into the pressure side and osteoblast cell into the tension side. The lag phase will be longer if we have applied a heavy force and shorter if we apply a light continuous force. In the post-lag phase, it is represented or characterized by the removing of hyalinized area and the occurrence of tooth movement. So post-lag phase, the tooth movement will be occur after the end of the bone remodeling. If we want to know what happened in each phases of the tooth movement, we can look for this table include the information of the changes of what happened in each second or minute or hours or days in each phases. You can read it. You can see that in the initial phase, within less than second, there will be a PD ligament fluid incompressible and the alveolar bone will be bent and the single electrical signal will be generated. In the next second, there will be a PD ligament fluid express tooth movement within the space. After 3 to 5 seconds of force application, the blood vessel within the PD ligament will be compressed on the pressure side and dilatation on the tension side. Then we will enter into the lag phase that will be range from minute to hours. In the first minutes of lag phase and of application of force, of course, the blood flow will be altered. The oxygen, as we mentioned, will be in the tension side increase and decrease in the pressure side. After hours, there will be a metabolic changes occur. Chemical messenger will be activated and act on the cellular activation. After hours, 4 hours, in the lag phase, there will be a cellular differentiation of the cells that are present in the PD ligament. And there will be a activation for it. In the post-lag phase, there will happen of a tooth movement will be begun as the osteoclast and osteoblast cell remodel the bony socket. So these are all the changes will happen in each phases. I hope it's clear for you. This is the end of our lecture today. Thank you very much for your attention and goodbye to the next lecture in next